We had our empty shell of the hull, and we're going to fill it with some of these structures that'll hold rigging and some seating. We're going to make a deck. Flip this upside down. Make a deck with a little structural support, a hole for a hatch cover, 2 mast partners. It's going to have these cleats that it goes on to support it. We are going to make this main thwart and a Daggerboard trunk that gets secured in there, and then this will have a hole going all the way through, fiberglass on the inside. This gets secured in this step also with those cleats. I haven't yet put in the structural supports on these lateral pieces. There's going to be a little shelf at the back and a rear tank. This rear tank cover, a little structural support. Inside this rear tank, I did a Mizen partner. This should be airtight. I haven't done any finishing on this, but I am gonna put some goop on the inside to help seal that up. And then when this gets secured, all this is gonna be airtight, and then that's gonna be flush. There's gonna be another hole up here for the partner so that that mizzen mast can come through. We're gonna end up doing a couple other things at the back in the next step, but at the end of this phase, the boat should look like this. I start with putting an outer gunnel on the bare plywood plank. I had some strain in the ply towards the bow that was testing what the plywood can handle, and this will secure it at the chine and prevent something like a massive crack in the plank, which could be a pretty serious problem at this point. My planks have excess material up past the shear line, so I use a square to measure down to the top of each frame on the inside, and then transfer that measurement to the outside of the plank. Then I can clamp a long batten on and make a decently fair curve to draw where my shear line will be. I had an issue with the frames towards the bow twisting, and that caused them to shift a little up and down because I planked one side at a time. So I make the best curve that mostly meets with my frame markings. This boat has a high shear line that's going to catch a lot of wind, but it's a trade-off. It's also going to allow for a good rowing position. It's going to allow the boat to heel over a lot, and it's going to allow a pretty good load capacity for a boat this size if you need it. If, though, you want that shear to be lower, this is a good time to make that adjustment. You need to adjust the center thwart to be a little bit lower for a good rowing position, and you got to lower that Daggerboard case a little bit, and so you need to make a couple adjustments. And it sounds like a lot of work, but really, that much of an adjustment at this point is not that big a deal. So, an inch or 2 or 3 lower of a shear line to taste isn't going to cause a gigantic hassle. I use ash for my gunnels. I find it the hardwood that has the best value. And for pieces like these gunnels that are going to get banged up, I think it's worth the trip to a real lumber yard to find this material. I started with a 14-inch board and milled 5 lengths, measuring 5/8 of an inch by 1 1/4 inches by 14 feet long. Outer gunnel port, outer gunnel starboard, inner gunnel port, inner gunnel starboard, and then pieces for the inner gunnel spacing, so that's 5 lengths. Then I rounded off the exposed edges with the router. I didn't find I needed to steam these pieces to bend them to that shear, but it wouldn't be a bad idea to get rid of some of their tension. Following that shear line I drew with the batten, each of these gunnels gets glued and clamped. With every clamp I have, one gunnel at a time. The first one was attached with Type on 3, but the second one I switched to PL because it has a longer working time. A day or two later, the clamps come off and the excess shear gets cut off with a handsaw later in the build, but I put the clip in here. I came back with a belt sander and brought down the ply to the gunnel. When I get to finishing, I'll clean it up some more, but a rough finish is fine for now, and the boat is really starting to look good. Next, I move on to the Daggerboard case. Sailboats move faster and towards the wind by making a wedge out of the forces of the wind and water. And this Daggerboard is my preferred way on a boat this small to deploy a board down into the water to do the water's half of the wedge. You could do a lee board over the side, which makes for more space in the boat, but on many boats, they're an eyesore. You could do a centerboard, but that's more complicated and heavy than a boat this size needs. You have to ship the board when it's up, but the Daggerboard is easier to make and it's easier to maintain. The Daggerboard trunk is the only piece in this fitting out section that gets a diagram, but it's not too hard to fit one without the diagram, and even this one diagram is a little inaccurate. I made a mistake of measuring the front edge when I was measuring the front edge of the case. The bulkhead had bowed a little from the force of holding those two planks apart, and I measured that bowed bulkhead. I fit the Daggerboard trunk to the bowed bulkhead instead of to the bulkhead when it got straightened out. And so that created a little bit of a gap. I'll explain in more detail when we get to that part of the fit. I made my Daggerboard trunk by clamping together 2 pieces of 3/8 plywood, cutting them to about 23 inches by 14 inches, and then moving in on the measurements of the trunk one side at a time. I lay these clamped together pieces in place on the sole and then mark that bottom edge by sliding a pencil flat across the sole, and I cut that edge with the skill saw. The skill saw does a decent job on an arc like this, but I clean it up with the belt sander. Then I push the trunk flush up against the bulkhead and maybe use a little block if I need to, and run that pencil along that front edge to measure that distance and draw that line and then cut that edge. This is where that bulkhead was bowing from the inward force of the side planks. Later, when I straightened it out, it created an angle of a gap, a little slice of gap between the trunk and the bulkhead, and that opened up to maybe 1/8 of an inch. I ended up leaving the gap, but the trunk would be more secure and less prone to rot with a proper fit. Anyways, with my bottom and front edges measured and cut, I kept going counterclockwise, and I wanted that center thwart to be level fore and aft. So using that construction string that I still had stretched across my spreaders, I measured down to the bulkhead, and then I can continue that measurement back from the bulkhead to make a line for the top of the trunk. The aft edge of the trunk will limit the rowing seating position, and to make a little space to sit without your crack riding on top of the Daggerboard opening, I made my trunk 21¼ inches long, front to back. You could add an extra inch or 2 or 3 to get a little bit more seating for a rowing position, and that actually would level out the balance of the boat better. But it adds weight, it takes up cockpit space, and I'm going to operate this boat sitting on the sole or sitting on the rail, and that seating actually encroaches on where I'm going to be sitting when I'm sailing this thing. One of the interior Daggerboard trunk panels gets the supports laid out and then glued down. I made these supports 3/4 inch by 1 inch because the Daggerboard is going to be just shy of 1 inch thick. So that 1 inch is the gap between these two sides of the Daggerboard trunk. Most of these are milled down from hardware store dug fir, but The trunk timber pieces that contact the daggerboard are from hardwood at the front edge and the back edge of the opening. This is where the daggerboard will bang against them, especially if you're on the ground. I should have used oak. That would have been more durable than ash, but I had ash on hand. A simple sled on a table saw makes that diagonal cut for the front timber. I left a little gap at the bottom of the rear triangle for drainage. Might have tried a few grains of sand in the glue to keep the pieces from moving because I got slight movement on one, but maybe it would have been a place for water to get in. A trunk like this is a weak point in a boat, and it's a common culprit when you're looking for a rod or a leak. Next, I put a layer of fiberglass in the trunk, just the parts that'll be exposed to water. Maybe it was a mistake I made out of vanity, but I hit the bad face of each plywood panel inside the trunk, which created some gaps and some imperfections that needed to be filled with thickened epoxy before fiberglass went down. This fiberglass surface doesn't have to be pretty, it's purely functional. It's going to be hidden in that trunk. With the epoxy cured, it's important to align the panels carefully when it comes back together with glue. A little trick to get clamping pressure in the middle of a span is to create an arc in the piece that clears that span. That piece of timber that I'm going to clamp up is going to have a little bit of a curve on one side. I had enough set time with the PL Premium that I had already put glue on when I started making that curve by planing some material off the ends, then flipping that curved face to face the piece I'm gluing together to get that clamping pressure in the middle where it's hard to reach. Once the glue dried, I set the trunk in behind the bulkhead to mark placement of the two brace pieces at the bottom of the trunk. The center line is still drawn on the sole. The center line is still drawn on the bulkhead. That construction string is still stretched across the center of my spreaders. So that makes it pretty easy to get the placement of this Daggerboard trunk right. It is important to make it straight from front to back and to be straight vertical. I imagine you could put it on one butt cheek to the side and clear up some seating space without noticing a performance difference, though. It doesn't have to be exactly centered, but it's pretty easy to get it centered. This part is where I straightened that bow out of the bulkhead with a piece of timber across the top, and I opened up that gap at the front of the trunk. Maybe it was laziness that influenced the calculation that the risk of making a cut in that laminated trunk was more than the risk of leaving the gap. It just wasn't worth fixing, but it is a place where water can get in, and it could cause a problem in the future. I don't have the right video of it, but I drew out placement for pieces to brace the bottom, removed them to drill through the sole, replaced them from above and weighed them down with bricks, and then drilled and screwed them from below. This allowed me to test the fitment before gluing and then screwing them down, double checking fit and then cleaning up the excess. I ran a 1-inch by 1-inch piece athwart ships at the aft end of the trunk and cut a notch into the trunk to bed it in. This will support the main thwart through the trunk. Also, the top of the trunk gets cleats to help support it mating with the main thwart and to support the opening, and all that gets cleaned up before glue later. Most of fitting out is making and attaching the deck and seating. I tried to edit this in an order that makes sense, but it's not necessarily the order that I worked in. First, I'll go through making the deck. The angle the deck rises as it approaches the stem is a matter of personal taste, and you can make it level if you wanted to, but I find it pleasing to make it line up about with the shear line as it rises up towards that stem. This gets laid out first, and then a rough placement where this deck's going to go gets drawn on the hole. There are a couple approaches to fitting a piece like the deck, and in this build, I almost exclusively used measuring tape. For some measurements, I spanned the distance with 2 timber scraps and clamped them together at the correct length. Another way is a tick stick, but it's fun using a tick stick, but I only get moderately accurate with those. Maybe the best technique is to cut and tape cardstock and to make a pattern. I didn't do that until I had to get really precise with the Mizen step. My deck fitment is just good enough, barely good enough. But this is one of those times where I praise the use of epoxy to fill the gaps that I'm too lazy to fill with good fitment. I measure my deck mostly with a steel square and then transfer the measurements onto that 1/2-inch ply. There should be a diagram showing now of how I put that on that 1/2-inch ply. A good thing about this boat is most of the deck is an isosceles triangle with straight edges. It isn't until aft of that second station that the edges curve in. I was quickly reminded of my planking error that put a twist in the station 2, and it caused some fitment complication with this. The process of fitting the center thwart and the rear tank and the shelf, it's the same process as the deck, but these pieces are simpler and my fitment turned out a lot better on those. The deck required the most tuning to get right. It's by far the worst fit of any of these pieces. All these pieces need braces to rest on called cleats. These cleats get glued up against the planking. About 3/4 inch square strips of timber, just decent big box fir should suffice. I measure their lengths where the decks are lined up, and then measure the bevels. And then I make notes of what the bevels and all these measurements are, and then cut them to length and use a spoke shave to cut those bevels. I use a triangle calculator website to calculate bevel measurement, to measure down from the edge about how far it would go to make the correct bevel, but it's easier just to draw an angle on the end of each cleat. For cleats at the deck and slightly for cleats at the main thwart, that bevel changes across the span of each cleat. This means you got to mark the bevel at the fore end of the cleat and then the aft end of the cleat. And then you've got to cut a bevel that makes a twist across the distance of the cleat. It's just like the frames towards the bow. The twist in the bevel should get straightened out when the cleat is pulled up against the plank, because the twist in the plank is what's being accounted for. Twisting a cleat like this is no easy job without a little help, so I use a table saw to make curved cuts into cleats at the bow. These cuts allow the cleats a little flexibility to make that twist. You should already have decks and seats fitted with cleat placement penciled in before thinking about glue. I use a combination of clamps and screws to glue these to get clamping pressure. I tried cutting a plastic scraper to hide screw heads on the ply, but the plastic just warped and marked up my plank anyways. When it came to the main thwart, fitment was relatively easy. There was a spot where my butt joints on the planking needed space made for them, and I ran that thwart laterally across a table saw to remove that material. It, it surely isn't the safest technique. Deck and the rear tank get the material cut out to fit the round hatch covers. I'm not securing these yet either. these pieces, that tank cover, the main thwart, the deck, they get timbers glued to the bottom for additional strength. But there's an issue that needs to be addressed about how some of these timbers have a taper. So this piece at the edge and then this piece in the middle, these lateral timber braces, they get tapered to spread out that force. Because if you don't taper it down to spread out that force, then all that force is going to get focused right exactly where you cut it off at the end. This one gets cut square at the end because it's going to get a piece that's prettier than this to support that from below. This is the same on the main thwart. You can see this main thwart has a couple pieces that are tapered, but then this main timber on the thwart is going to get a prettier piece than that supports it directly under that timber. Because if you support it My next job is making the Mizen mast step. It's the most complex part of this whole build. I considered just skipping it, but I wanted the flotation chamber at the stern to actually function as a flotation chamber. This piece needs to be airtight if that tank is going to keep air and water from trading places. And if it's going to keep that capsized boat floating high enough to bail out, I need to make this seal excellent. So this is where I used cardstock to make a pattern. The mizzen mast opening is 2 inches. This mizzen isn't going to carry much sail, so I'm not making a thick mast for it. For simplicity, the rake of the mast, it's at the same angle as the rake of the transom. This whole process I went through is a good argument for epoxy. If I didn't live in a desert where the summers reach 120 degrees, I would have gone that route. All these cleats and bevels, they're too complex. I'm not going to narrate every step in this tedious process, but these next clips should be enough guidance that you can make this piece well enough. Cutting the mast opening and the tank cover is a little stressful. My best approach was to set the cover on the cleats and then come in through the hatch opening with a pencil to mark the location so that I could center a pilot hole. Then I get that pilot hole big enough that I can put my finger in and then a pencil, and I just slowly worked my way outwards with a jigsaw and then eventually a rasp to make it mate flush with that airtight partner internal. It helps to go slow and grit your teeth. My fitment ended up pretty good by my standards, and I was happy to finally round over the top edge with the router without having screwed everything up. The next step of the video is securing the Daggerboard trunk in the main thwart. I lined up 3 screw pilot holes in the sole to center on the trunk's bottom spreading timbers. A hole in the sole is drilled for the lower opening to make it easier to come in with the flush bit router later, to come in from below and router out that opening. As mentioned before, this trunk is a common source of problems, especially along glued seams, so sealing it up properly is important. I used plenty of that expanding PL premium and spread it evenly across mating surfaces. Then after the trunk is tapped into place, I can continue these pilot holes from below and screw them up into the trunk, not near where the water is going to be. And then I can put screws in from the bottom for clamping pressure against that expanding poly glue. A 4th screw through the bulkhead, from the front of the bulkhead to the trunk about halfway up, assures the trunk is aligned vertically as the glue cures. The main thwart gets a hole carefully centered in the top. That's where that opening can get routed out. And once that hole's drilled, then I can prep and glue this main thwart in place. I use weight and screws as clamping pressure on the cleats and on the trunk, and clamps on the bulkhead timber piece. I placed that lateral timber at the aft of the thwart in last, which might have been a mistake as the expanding PL didn't bed in the notch quite right. Once the glue is cured, that top opening gets a flush trim router bit and then a round over bit. Doing the same to the fore and aft edges of the seat, running a flush trim bit and then a round over bit. The bit doesn't quite reach the edge once that thwart is glued in, and so the excess material gets cut off with the handsaw and then rounded over with the rasp and then sandpaper. Onto the deck and mast partners up front. These partners are to accommodate a 2 7/8" square mast. The placement of these mast partners in your deck is based on their distance from the leading edge of the daggerboard. So what I did, the leading edge of the daggerboard is it comes out the bottom of the case. So what I did is I dropped a plumb line and marked that on my construction string, and then measured back from that, and then this rear mast partner between 34 inches and 3 feet is good. I think this at 34 inches is going to fit the balanced or standing lug sail that I plan on putting on this. But with the sprit sail made out of the tarp, I think 3 feet would be better, but 2 inches may or may not, I may or may not notice a difference in performance. This front one, 4 feet forward to the rear edge of that mast partner. That should make for that big, what is that, 8x10 sail to be pretty well placed there. But then also I can scoot a sail with my lug sail. I can put the mast up there for that and then use the Mizen and balance that out. Also, put this stuff away. Underneath, I put this brace for the rear and tapered at the edges, but then this one's going to get structural support directly on it. And then for the forward step, I didn't brace anything. I think this 1/2 inch ply should be okay holding it with this, with not much distance between it and the planking. I installed cleats for a small shelf at the transom. This shelf is only as deep as the 2-inch Mizen mast opening, and then 2 cleats. So 2 3/4-inch cleats. It's going to be 3.5 inches deep, this shelf at the transom. It's a workaround to avoid quarter knees and an extra mast partner. It's also just going to be a good spot to put clutter when you're on the boat. The shelf is 1 inch below the bottom of the inwale. So it's 1 inch below the bottom of the gunnel. So you measure that gunnel on the shear line, transfer that measurement to the inside, and then add 1 inch. I'm going to cut a hole for the mast to fit the mast vertically in the next phase of the build. Right now, I'm just getting these pieces fitted. Finally, I needed to seal up the chambers at the bow and stern to make them airtight. I measured out a couple plywood pieces and fit them into corners, and used plenty of PL premium to expand and seal up the mating surfaces. Then I used some spare timbers and some clamps and held them in place. That PL, it doesn't cure as hard as epoxy, but it's still a mess to clean up after it's cured. And finally, the boat is looking beautiful. This isn't the complete fitting out process, but the rest of it's going to go in the next chapter with spars and rigging. This boat sure, this boat sure looks good as pieces start to fit and edges get rounded over. And you kind of fantasizing about sailing this thing.